Hello everyone. Okay, so in this video we are looking at the integrals of exponential functions. So these are the key rules here. These are in your log tables. So what we learned in calculus was, right, e to the x. If I was to differentiate e to the x, I get the exact same thing. And that goes for integration as well. Obviously, if I differentiate e to the x, I get e to the x. If I differentiate again, I get e to the x. So it makes sense if I was integrating e to the x, I would still get e to the x. But I just have to remember, I have to add my plus c. Now, what if I have something like e to the ax? So e to like the 2x, for example. So remember, when we're differentiating, I keep it the same, but then I multiply by the derivative up here. So it'd be 2e to the 2x. Well, that's the same when we're integrating. It's just I divide by the derivative of the angle, or the coefficient of this like kind of x up here. And then finally, what if I am integrating a to the x? So some number like 3 to the x, 4 to the x, whatever, to the power of x, I'm integrating that. Well, that'll just be a to the x over ln of a plus c. So when differentiating, we multiply by the derivative of the exponential part. So when integrating, we divide then. So just looking at these examples here. So 5e to the 2x. Well, the derivative of 2x is 2. We now divide by the derivative. So it's 5e to the 2x divided by 2 plus c. That's my answer there. Here, 3 to the e to the x plus 4. Well, now I'm getting the definite integral between 5 and 2. So 3 to the ex, well, that will just still remain as 3 to the ex. And 4 will just be 4 to the x. I'm integrating it between 5 and 2. I sub in 5, we 3e to the 5 plus 4 times 5 minus 3e to the 2 plus 4 times 2. And then add it all up together. And, well, that's it. Not really. It's going to be 3 to the e to the 5 minus 3e to the 2 plus 12. And that'll be my final answer there. And then finally, I'm integrating 8 to the x between 2 and 0. Well, that will just be 8 to the x over ln of 8 between 2 and 0. Sub it in, 8 squared all over ln of 8 minus 8 to the power of 0 all over ln of 8. And my answer finally will be 63 over ln of. Right? And that is it. Let's look at some exam questions here. I need to find the definite integral of between 2 and 0 of 12e to the 3x. Give your answer in the form a times e to the b minus 1. So I'm integrating between 2 and 0. This will be a divide by the derivative of 3x. So it would be 12 divided by 3, which is 4. So it'll be 4 to the e to the 3x. Sub it in. I'm going to have 4e to the 3 times 2 minus 4e to the 3 times 0, which is going to be 4 to the e to the 6 minus 4 times e to the 0, which is going to be equal to 4e to the 6 minus 4, factor out of 4 here, e to the 6 minus 1. That is the answer there. And that is in the form it asked me for. Let's look at this one now from 2023. Work out the value of b. So I'm integrating now this function between b and 0, and it's equal to e. And I need to find out what e is. Well, the integral between b and 0 of b to the ebx, where b is a constant. So this will now just become, well, b divided by b is 1, so it'll just be e to the bx. And the integral of that between b and 0 is e. So sub it in. I'm going to have e to the b times b minus e to the b times 0 is equal to e. E to the b squared minus e to the 0 equals e. Sum it up here. So eb squared minus 1 equals e. eb squared equals e plus 1. Now I need to use my logs. So this is my base, this is my answer, this is my power. So to convert it to logs back, it'd be log base e of e plus 1 equals b squared. And then finally to get b on its own, I square root all of this. So remember BAP, B, A, P. So put that in my calculator. I'm going to get something crazy. Well, did it say, once I work out the value of e, that's the value of e. But if we were just putting in our calculators, I suppose, it would be where on earth is e? Ding, 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 ding. Then square root that. E. One. That is going to be b is equal to 1.14598. Right, let's look at this one now from 2022. Find the value of g of 4. Give your answer correct to 4 decimal places. G of 4 is just going to be equal to 2 minus 1 over e to the power of 4. Give your answer correct to 2 decimal places. 1 over power of 4. That is going to be equal to 1.9817. Then what's the limit of x goes to infinity of g to the x? Well, the limit of x goes to infinity is going to be 2 minus 1 over e to the infinity. Well, that would be 2 minus 1 over infinity, because e to infinite values is going to be a massive number. And then anything divided by infinity is 0, so it needs to be 2. 2 minus 0, and the answer is 2. Then solve the following equation. G of x equals a quarter. So 2 minus 1 over e to the x is a quarter. Multiply across by 4. Multiply across by 4 e to the x. So I'm going to have 8 e to the x minus 4 is equal to e to the x. Bring my e to the x to one side. 7 e to the x is equal to 4. E to the x is equal to 4 divided by 7. Then ln of 4 to the 7 then is equal to x. But it says give your answer in the form ln a minus ln b, so it'll just be ln 4 minus ln 7 to x. Right, next one now. Finally, find the integral between 0 and 5 due to the x. Give your answer in the form a plus e to the power of minus b. So 2 minus 1 over x. So the integral between 5 and 0, 2 minus 1 over e to the x. That's the same as the integral between 5 and 0 of 2 minus e minus x, which is 5, 0, 2 to the x. This is going to be plus e to the minus x. So I'm dividing by the derivative of minus x, which is minus 1. So it'll be 2 divided by minus 1, change the sign, it'll be plus 1 there. Sub it in, and I'm going to have 2 times 5 plus e to the minus 5 minus 2 times 0 plus e to the minus 0, which is going to be 10 plus e to the minus 5 minus 1. So my answer here will be 9 plus e to the minus 5. Answer there. Right, and that's it. That is exponential functions there. So I hope this video was some help to you guys, and I'll catch you guys later. Bye.